This video provides a deep dive into the shifting dynamics of the wholesale electricity market, or WEM, in Western Australia. We move beyond simple observations to uncover the hidden causal drivers behind the recent collapse in gas peaker revenues following the rapid entry of battery energy storage systems, or BESS. Correlation shows that revenue fell as battery replacement grew. It gives us a prediction, but it lacks an explanation. Causal inference is our what-if machine. You might have heard people say that correlation does not prove causation. Why is that? Let's explore a simple example. Consider this. Ice cream sales and the number of people swimming move in almost perfect lockstep, a correlation of 0.97. But we know the truth. The summer heat drives both. Check out these scatter plots from real wholesale electricity market data. On the left, battery replacement FCAS capacity versus peaker revenue shows a clear relationship, an R-squared of 0.73. On the right, the energy channel is a total cloud, barely above chance. The FCAS channel is 3 times more explanatory. But even the FCAS scatter can mislead if we read it naively. Solar growth and shifting demand are the heavy hitters here. They drive battery replacement investment and suppress energy prices at the same time. The solar and demand block contaminates the signal. We are not measuring battery replacement alone. This is where the directed acyclic graph, the DAG, comes in. By mapping out how solar influences both battery capacity investment and gas peaker revenue, the DAG tells us exactly which variables to control for and which to leave alone. This is the difference between a naive regression and a defensible causal analysis. Think of a DAG as your causal map. Every variable is a node, and every arrow represents a direct influence. When solar drives battery capacity investment up and peaker revenue down simultaneously, it creates a backdoor path, a non-causal shortcut that inflates our battery capacity investment estimate. By controlling for solar, we shut that back door. The path turns green, it's accounted for. We must also watch the offer schedule. This is the mediator, the actual mechanism battery capacity investment uses to undercut gas peakers. If we control for this, we block the very effect we are trying to measure. Likewise, the spot price signal is a collider. Including it would open a false path that does not exist in reality. Let's take the complete DAG and focus on a single causal chain. Battery deployment enters the FCAS markets, contingency and regulation, directly displacing gas peakers that previously held those contracts. This is the primary money pathway, so let's follow it. Before significant battery participation in the FCAS market, the peaker fleet earned $370 million in FCAS revenue over a single summer quarter. After batteries entered the FCAS market, gas peaker revenue dropped to $114 million, a fall of 69%. In spring, the collapse was even sharper, 92%. And here is the key test. Spring energy prices rose $45 per megawatt hour in the same period. Only the gas peaker displacement can explain a 92% FCAS collapse alongside rising energy prices. The DAG guided attribution is straightforward here. In summer, autumn and winter, period 1 had 0 batteries FCAS participation. There is no confounding to remove. The P1 baseline is clean. Across those 3 seasons combined, the peaker fleet lost $734 million. Batteries via FCAS displacement account for $420 million, or about 57%. Solar and structural demand account for the remaining 43%. Energy arbitrage is effectively 0. What happens if Western Australia adds 500 megawatts of new battery capacity investment? Because our model uses a causal dose-response relationship, we can say with confidence that peaker FCAS revenue would fall by a further $108 million per quarter. At 1,000 megawatts, that's $216 million. These are not trend lines, these are causal estimates. Causal analysis is transparent about its assumptions. We assumed a linear dose response, so each 100 megawatts of batteries reduces FCAS revenue by approximately $21.6 million per quarter. We assume the P1 0
battery's baseline is clean, which the fleet timeline confirms for 3 of 4 seasons. And we assume that the residual solar and demand effects are adequately captured by interval level conditioning. Transparency about assumptions is what makes this defensible in regulatory and investment settings.
Causal analysis provides a roadmap for everyone in the market. For investors, it's a defensible edge. For regulators, it's the proof that battery capacity investment, not solar, is the dominant driver of the FCAS collapse. For developers, it's a guide to which market segments remain robust.